Welcome to the Math Record. Today we'll be covering indeterminates and the Law Hopital Rule. This video will cover part 9 of chapter 2. Okay, let's begin. So what is an indeterminate? Well, basically an indeterminate means that you can't determine the limit of something. So by using indeterminates, we could solve things like 0 over 0 or like infinity over infinity. Like if we have a really small number over a really small number, you could actually sometimes get a numerical answer like 2 or something. Or if you have something like infinity or infinity, which is like two really big numbers, but they might come out to like an actual number. So basically, we already introduced the idea of indeterminate in chapter 2, part 3 of our calculus class, when we had something of a limit as x approaches 0 over of sine of x over x, which we told you to memorize is saying it's just equal to 1. Well, we have the idea of Law Hopital's rule, which we use to find out why it is equal to 1. So the general idea of how to do Law Hopital's rule and indeterminates is that if the thing isn't indeterminate, the equation isn't indeterminate, then you can use Law Hopital's rule. So the only indeterminates is 0 over 0, infinity over infinity, 0 times infinity, or you could say infinity times 0 is basically the same thing. And you have infinity minus infinity, or you have 0 to the power 0, or you have infinity to the power 0, or you have 1 to the power of infinity. These are the only 7 cases. 0 over 0, infinity or infinity, 0 times infinity, infinity minus infinity, 0 to the power 0, infinity to the power 0, and 1 to the power infinity. These are the only cases for indeterminates. So these are the only indeterminates. Okay? So if you have any of these cases, basically all you could do is that you could use the Law Hopital rule. So you could always use this rule. So the rule is basically if you have a limit as like x approaches like some kind of number, right? And you have two equations where you have f of x over g of x, well generally f of x over g of x, then all you have to do is that if you want to find the limit of this, all you have to do is that you could just say it's taking the derivative on the top all over the derivative on the bottom. And that's all you have to do. That's basically, it's just that simple. You just have the derivative on the top divided by the derivative on the bottom. So you could keep doing the Law Hopital rule over and over again. Like basically, let's say f of x divided by g of x is 0 over 0, right? Well, you could use the Law Hopital rule. So if you plug in the derivative, the derivative of f divided by the derivative of g, right? And you plug in x is equal to c, right? If f of c divided by the derivative of c, right? The derivative of f divided by the derivative of c, and that's still 0 over 0, you could use the Le Hopital rule again and take the derivative of the derivative. And then you just do the double derivative of x and double derivative of g. We'll be showing examples of how this works, basically. So let's first start off with the more common cases, which is basically the 0 over 0 and the infinity over infinity. So we're just going to show one example for this because they both basically do the same thing. And we'll be using it with the sign. So as we have limit as x approaches 0 of sine of x divided by x, right? So the idea is that first you always got to check if it's indeterminate. After you check it's indeterminate, if it is, then basically you just use the Law Hopital rule. It's basically just a two-step process. Okay, so first step, 0, right? Because we have x approaches 0, so let's plug in 0, right? So sine of 0 is 0, okay? And then x is equal to 0. Okay, so this is an indeterminate because sine of x divided by x when x is equal to 0 is just 0 over 0. So if it's a 0 over 0, it's an indeterminate of form 0 over 0, right? So it's one of the 7 forms. Since that is an indeterminate, now we can use the Law Hopital rule. So the Law Hopital rule, we do the derivative on the top. So the derivative of sine of x is cosine of x. the derivative on the bottom is derivative of x. Derivative of x is just 1. So is this an indeterminate? Well, we just plug it in. Well, cosine of 0 is 1. So 1 over 1 is not an indeterminate, right? Because this is not any of the indeterminate forms. There's only 7 of them, and this is not one of them. So basically, 1 divided by 1 will technically be your answer. So that's all you have to do. So now you have cosine of 0, which is 1. So 1 divided by 1 is 1, right? So we have sine of, so the limit of x approaches 0, a sine of x divided by x is equal to 1. And that's because of the Law Hopital Rule. So that this is in the form 0 over 0. But you could also use this idea for infinity or infinity. So we're not going to show an example, but it basically does the same thing, which is basically if the first equation, the sine over x, like if that was infinity over infinity, then basically just take the derivative on the top, divided by the derivative on the bottom. And if that is not an indeterminate, then whatever that answer is basically going to be your limit. And that's why we say that if there is something like 0 over 0, like a really small number over a really small number, there sometimes is a numerical answer. And in this case, sine of x over x is 1. It might seem impossible to do, but if you understand the Law Hopital Rule, which is pretty simple, you'll get the answer. Okay, so that was only the 0 over 0 and the infinity over infinity case. Now we're going to tackle the product one, which is basically only the 0 times infinity case, right? So this is our third case. The first two was 0 over 0, infinity over infinity, right? So for this case, basically all you have to do is, let's say we have a limit as x approaches 0, right? Oops. Okay. And you have two equations. You have f of x times g of x, okay? So you have these two equations. Well, basically, if f of x is equal to 0, and if g of x is equal to infinity, or negative infinity, it basically just has to be infinity. All you have to do is, you gotta make it into the form 0 over 0, or infinity over infinity. So what I mean is that, since one of them is 0 and one of them is infinity, right? It doesn't matter which one is infinity and which one is the 0. Basically, the idea is that you just need to keep track of where it is, right? So f of x, let's say that one's a 0, and g of x is the infinity. It doesn't have to be 0 times infinity, it can be infinity times 0. It doesn't matter since it's multiplying. But basically, all you have to do is that you're going to have 0 times infinity. And to get that into a 0 over a 0 form, all you have to do is just say you have f of x divided by 1 over g of x, right? Because basically this is the same thing as saying this. They're the same form, right? Because f of x, right, divided by 1 over g of x is you're dividing by something that's already dividing. So you're dividing by 1 over g of x, right? Which is basically the same thing as saying f of x times g of x. So these are both the same thing. You're just writing it in another form. So in this form, basically it's 0 over 0 because f of x, right, is our 0. And 1 over g of x, our g of x is in infinity, right? So 1 divided by a really big number, it just becomes a really small number, right? So a really small number is basically just going to 0. So it's just 0 over 0, right? And that's basically, we're going to put it in the case of 0, 0. Or if you want to put it in case infinity over infinity, well, you just want g of x on the top now, right? So it's just g of x over 1 f of x, right? Because g of x is infinity, and f of x is 0, right? So if x becomes 0, as f x approaches 0, then you have 1 over 0. 1 over 0 is basically just infinity, because it's a really big number. So it's 1 over infinity. Now we're in case 0, 0, infinity over infinity, right? And that's a general idea of how to use the product rule. So if we have 0 times infinity, we could rewrite it as case 0 over 0 or infinity over infinity. And that's why I said earlier, it just has a few extra steps. So let's try like an example. Let's try limit as x approaches infinity of x times ln of x. So is this in case 0 times infinity? Well, you just have x approaches 0, right? So x is equal to 0. So you have x equals 0, that's 0, times ln of 0. ln of 0 is basically just infinity, right? Because the graph looks like this, right? So as it approaches infinity right here, it's going to approach like negative infinity. But it doesn't matter if it's negative infinity. It just has to be some kind of big number. So the idea is now we could do the Law Hopital Rule. So the general idea is that you could either have x divided by 1 over ln of x, right? Or you could have ln of x divided by 1 over x. It doesn't matter which form you use, but generally I like to keep the easier one on the bottom. So what I mean by that is that I like to keep polynomials on the bottom. Because taking a derivative of anything like trig or like logs or like exponents are a little bit harder. So usually I like to keep the polynomials on the bottom so that we had to do less work. So we have limit as x approaches 0. So we're going to use the case ln of x divided by 1 over x. Because generally it's easier. If you want to use x divided by 1 over ln of x, that's okay too, but it might be a little bit tougher. So, but they both should technically get you the same answer, right? So we need to check if this is indeterminate. So we have 0. ln of 0 is infinity, right? And 1 over 0, because x is 0, right? So 1 over 0 is just infinity. So we have infinity or infinity. So this is an indeterminate. It's an indeterminate in case infinity over infinity, right? So it's one of the 7 cases. So because of that, we could take the derivative on the top and the derivative on the bottom. So the derivative on the top, which is ln of x, is basically 1 over x, right? And the derivative on the bottom is just negative 1 all over x squared, right? And that's basically how simple it is. So now we just now we just have 1 over x divided by negative 1 over x squared, right? Which is the same thing as saying 1 over x times negative x squared, right? Because dividing is basically multiplying by the reciprocal. So multiplying by x squared divided by negative 1, which is negative 1x, negative x squared. So negative x squared times x is just negative x, right? So basically all of this limit of x approaches 0, x times ln of x, all that is basically just saying the limit as x approaches infinity, and it just basically equals this, because that's all you simplify to. So you have negative x. So negative x is not going to become an indeterminate of anything, right? Because it has to be one of the 7 cases, and for sure it's not going to be any of those 7 cases. So all you have to do is just plug in the x. So you plug in x's in here, right? So negative 0 is just 0. So that basically tells us that the limit as x approaches 0 of x times ln of x is equal to 0. And that's basically for the product rule for indeterminates. Now let's work on the next one, which is the subtraction rule, which is infinity minus infinity. So generally, there isn't a way, like a standard way to do this. The general idea of how to do this is that you're going to simplify the equation, and then you're going to like manipulate the variables around to see if you could like make it into like 0 over 0 or like infinity or infinity case. So it's always going back to 0 over 0, infinity or infinity generally. So I'll just show you an example of how this works, but it doesn't always apply to every case. So let's say we have limits of x approaches 0, and we have 1 over x minus 1 over sine of x, right? So let's see if it's infinity minus infinity case. So we put 1 where x is 0, right? So 1 over x is basically infinity. Sine of 0 is 0, so 1 over 0 is infinity. So this is an infinity over infinity case. So all we have to do is that since it's an infinity infinity minus infinity derivative, infinity minus infinity indeterminate case, then basically we use the Law Hopital Rule. So the first thing we have to do is Usually we always like to simplify. So the limit as x approaches 0. This simplifies to sine of x minus x all over x times sine of x, right? So let's see if this is any like indeterminate. So x is 0, right? So sine of 0 is 0 minus x, which is 0, so minus 0, all over x, which is 0, times sine of x, which is 0, so 0 times 0. So this simplifies out to just 0 over 0. So this is an indeterminate of case infinity over infinity. So because of that, basically all we have to do is that we could make it, we could use the Law Hopital Rule and look, we could check if it's going to become a another indeterminate or it becomes the answer. So since it's indeterminate in case 0 over 0, we could use Law Hopital. So Law Hopital, derivative on the top. So derivative of sine of x is cosine of x. The derivative of x is 1. So it's just negative 1, right? So the top is just cosine of x minus 1. The derivative of x times sine of x, well, that's a product, right? So you have to use the product rule for derivatives. So the derivative of x is 1. And then you multiply by the original function of the second one, which is sine of x, plus the original function of the first one, which is x, times the derivative of the second one, which is cosine of x. Okay, so now we have this. So is this a indeterminate? Well, basically we just plug in x, right? So if we plug in x, cosine of 0 is 1. So 1 minus 1, okay? And on the bottom, we have 1 times sine of x. Sine of 0 is 0, plus x, which is 0, right? Times cosine of x, so cosine 0 is 1. So 1 minus 1 is 0. 0 times 1 plus 0 times 1 is just 0. So this still is an indeterminate. So we could use the Law Hopital Rule again. So you can always keep using the Law Hopital Rule if it's indeterminate. So we're going to use it again. So the derivative of cosine of x minus 1 is basically just negative sine of x, right? So the limit as x approaches infinity. You always got to keep the limit so we know it's a limit. So the derivative of cosine of x is negative sine of x divided by the derivative of sine of x is going to be cosine of x. And we have the product rule again, right? X times cosine of x. So we have the derivative of x, which is 1, times the original function, which is cosine of x. Oops. Okay. Let's move this a little bit more. Cosine of x plus the original function, which is x, times the derivative. So derivative of cosine of x is negative sine of x. So now we have this. So is this an indeterminate? Well, we just have to plug in x equals 0, right? So sine of x, which is 0, is 0. Okay, so that's a 0. And cosine of a 0, which is 1, so this is 1. So 1 times cosine of x, so cosine of 0 is 1, so 1 times 1 is 1. And x times negative sine of x. Sine of x is 0, so negative 0, which is 0. And x is 0, so 0 times negative 0, which is 0. So it's 1 plus 1 plus 0, which is 2, right? So that is not an indeterminate form. So basically the answer would just basically be 0 divided by 2. So if it's not an indeterminate, it's going to be your answer. So 0 divided by 2 is 0. So basically the limit as x approaches 0 of 1 over x minus 1 over sine of x is equal to 0. And that basically just uses the idea of Law Hopital's rule. So all these indeterminates just use Law Hopital's rule, but in like kind of a different way. And now let's do the exponential forms. Okay. So the exponential forms are 0 to the power of 0, infinity to the power of 0, and 1 to the power of infinity. The three cases. Okay. The general idea is that if you have something like limit as x approaches like some kind of number, we'll call it c, then basically if you have two equations, which is f of x the power of g of x, right? You have these two equations. Well, basically, all you have to do is like, let's just say f of x is equal to y. I mean, f of x to g of x is equal to y. So we have f of x, the power of g of x is equal to y. And if we take the natural log of both sides, right, of ln of f of x, the power of g of x, right? Actually, we don't need that, right? So basically, since this is a log, we could just bring the exponent down. So the ln of y is equal to g of x times ln of f of x, right? So the ln of y is equal to g of x times the natural log of f of x. So using that idea, so the idea is basically is that if we have the limit of oops, we need a little bit more room. So let's write it a little bit smaller. So we have the limit as x approaches 0 of ln of y, right, of this equation, right? So basically this equation. And we take the limit of this equation, and it's equal to like some kind of like number, like let's say it's a, then basically this would mean that the limit as x approaches 0, I mean, not 0, sorry. This is supposed to be a c. As x approaches a c, then y is equal to just e of a, right? Does that make sense? Because ln of y is equal to a. So then basically y would just be, right, e to the power of a. Because e to the power of ln of y is just y, right? Ln of y is just equal to a. So if e to the power of a is equal to y, you basically, this is the y right here, and this is e of a, right? So it makes sense. So we're going to use this general idea to do all these exponential cases. So let's start working with the 0 over 0 case. Okay? So 0 to the power of 0, I mean. So if we had the limit, okay, of x approaches 0, and we have sine of x to the power of x. Okay? So what's the limit of that? Well, basically, we need to check if it's indeterminate, right? That's our first step always, to check if it's indeterminate. Sine of x, it's sine of 0 is 0. And x is equal to 0, right? So this is a 0 over 0 case. So 0 over 0, right? The sine of 0, 0, and x is 0. So this is a 0 to the power of 0 indeterminate case. So all we have to do is basically do what we did generally that I just showed like a few seconds ago. So we just have to say y is equal to sine of x to the power of x, right? So that basically means ln of y is equal to x times ln of sine of x, right? So the ln of this, ln of sine of x. So now we just need to use the Law Hopital Rule to do basically this. So is this a indeterminate? Well, we have the limit of x approaches 0 of ln of y. ln of y is just x times ln of sine of x, right? So let's kind of move this up. We get a little bit more room. Okay. So using this idea, is this an indeterminate? Well, x is 0, and sine of 0 is 0, right? And then if sine of 0 is 0, then basically it's just ln of 0. So what's ln of 0? ln of 0 is infinity, right? So 0 times infinity, that is a indeterminate form, right? So since this is another indeterminate form, all we have to basically do is just use the Law Hopital Rule. So our form for 0 times infinity, remember that form is basically just, if we have two equations, we just have equation 1, right, f of x divided by 1 over g of x, or we have g of x divided by 1 over f of x, right? So you just have one equation divided by the reciprocal of another. So we just need to choose one. And generally, we like to choose the one that's easier, which is usually the polynomial, so the x. So we're going to have ln of sine of x divided by 1 over x, right? This is the same thing as x times ln of sine of x. So all we have to do is just take the derivative of the top and the bottom, right? So the derivative of ln of sine of x is 1 all over. So first since it's ln and then sine of x inside, we have to use the chain rule. So the derivative of ln of x is basically 1 over x, but we have to keep what's inside still inside. So x will be substituted by sine of x times the derivative inside. So times sine of x times the derivative of sine of x, which is cosine of x. That's all the numerator, right? Now we have to do the bottom part, which is 1 over x. So the derivative of 1 over x, as I shown before, is just negative 1 over x squared. Oops, negative 1 over x squared. So basically, this is just cosine of x divided by sine of x divided by negative 1 over x squared, which basically the same thing as saying negative x squared times cosine of x divided by sine of x. So is this an indeterminate form? Well, we just need to plug in what x is equal to, right? X is approaching 0, so it's equal to 0. So 0 to the power of 0 is, 0 to the power 0 to the power of 2 is just 0. You keep the negative there, so it's negative 0, which is still 0, doesn't matter. So cosine of x, which is 1, because x is 0. And then sine of x, which x is 0, is basically 0. So 0 divided by 0, okay, that's still a indeterminate. So we have to do it again. So let's move this up so we keep getting room. So the Law Hopital Rule is basically sometimes really tedious because you always have to keep using the rule to simplify. But other than that, it's actually pretty simple. So the derivative of negative x squared times cosine of x is basically just going to be since it's a product rule, right? Negative x squared is one function and cosine of x is the other. It's got to use the product rule for derivatives. So we're going to have the derivative of the first one times the original of the second plus the original of the first. So times the derivative of the second, which is a negative sine of x. Okay, for our parentheses, and that's good. And then the derivative on the bottom, which is sine of x, is just cosine of x. So we have this. Move this up again. And let's simplify. Okay. So we have negative x times cosine of x. We could just leave that alone. X. And then this is negative x squared times negative sine of x. So that is just plus x squared times sine of x. All divided by our cosine of x. Right? So is this indeterminate? Well, remember our original equation was limit as x approaches 0, right? So as x approaches 0, it just becomes 0. So x is 0, so negative 2 times 0 is 0. Cosine of x, which is 0, is 1. Plus x squared, which is 0 squared, which is 0. Times sine of x, which is 0, because x is 0. So cosine of 0 is 1. Okay, so we have 0 times 1, which is 0, and 0 plus 0, which is 0. So 0 plus 0 is 0 over 1. This is not an indeterminate form, because an indeterminate is 0 over 0, right? This is 0 over 1, so it's different. So our answer is basically just 0 divided by 1, which is basically just 0, right? So our answer here is 0, but we're not done yet, right? So we said in our original equation that limit x approaches 0 of sine of x, the power of x. We already did all the calculations, right? And we got out where this is equal to 0. because we did all the math on it, which is 0 divided by 1 is 0, right? So basically, actually, sorry, no, sorry about that. We have limit as x approaches infinity of ln of sine of x over x is equal to 0. So basically, now limit as x approaches 0 of sine of x, the power of x is equal to e to the power of 0 now, right? So now it's equal to just 1. So that's basically how to find the limit for exponential. So when we convert it to this equation to a natural log, we had to convert it back. So that's why for that entire time where we did the Law Hopital Rule, we were working on this. And that's what got us to 0. And now we have to convert that back to our original equation. Okay, so now let's do the same thing, but now we're going to use the case infinity to the power of 0. So our example is limit as x approaches 0, where we have ln of x to the power of x. So we're going to do the same thing. We're going to say y is equal to ln of x to the power of x. So, oh yeah, first we have to check if this is infinity to the power 0. So we plug in 0 here. Ln of 0 is infinity. X is 0, right? So it's 0 to the power infinity to the power of 0. So it is that indeterminate case. So now we can set it equal to y. Now the ln of this, we convert it to ln of y is equal to ln of x to the power of x. So it's x times ln of ln, of ln of x. Okay? Don't forget the second ln, because you're taking the ln, the natural log of a natural log, right? Because this was our original equation, ln of x. So we need to find the natural log of our original equation, which is our ln of x. So our ln of our ln of x. So don't forget that. So basically, now we're gonna have to do the limit as x approaches 0 of ln y, right? So basically the same idea of what we just did in our previous example. So the limit as x approaches 0. So our ln of y is x times ln of x, right? So we're going to be doing this. So, okay. So now we're just going to have ln of x equals 0. So we need to know if this is indeterminate. So if x is 0, this is 0, right? Ln of 0 is infinity. So, sorry. So ln of 0 is infinity. So the ln of infinity is infinity, right? Because the graph looks like this. It might look like it's going to an asymptote, but it's not true. Natural logs do not have an asymptote. They're just going really, really slow, basically. So think of them as parabolas, but basically like not a really good parabola. Because a parabola is like going up really fast, but this thing is going like vertical. But basically a natural log is going horizontal. It's going to infinity, but it's just going really, really slow. So ln of 0 is infinity, and as ln of infinity is infinity. So you have 0 times infinity. So this is a indeterminate form of 0 times infinity. So you could use Law Hopital's rule. Okay? So using Law Hopital's rule, we have, since this is 0 times infinity, remember the rule for that is just fx divided by 1 over g of x. Or you can have g of x divided by 1 over fx, right? So, as I said always, just choose the polynomial one because usually it's the easier one to do, right? Because you don't want to put the ln over ln of x on the bottom because then it takes a little bit more work. So, ln of x on top divided by 1 over x on the bottom, right? So this is the same thing as this, right? So basically, since we have ln of x over 1 of x, we just do the derivative on the top. So the derivative of ln of x is basically chaining, right? So derivative of ln is 1 over x. So since we still have something inside, we gotta substitute the x with ln of x. And then you have to do the derivative of ln of x. The ln of x inside the ln of the ln. So you put 1 over x. I'm sorry if I keep using ln and not natural log. It's just how I prefer to say it. And the derivative of 1 over x is just negative 1 over x squared. Right? So this basically simplifies out to move the x squared to the top because you're dividing by something that's dividing. So that's just x squared, well, negative x squared divided by x. So it's negative x all over ln of x, right? So that's what it simplifies out to. So is this an indeterminate? Well, we just need to plug in 0, right? Because x approaches 0. So we have negative 0 all over ln of x. So ln of x, where x is 0, is go to infinity. This might seem like an indeterminate, but it's not. The only indeterminate forms are 0 over 0 and infinity over infinity, right? Well, there's 5 others, but these are the general ones. And since these are like the only... But if you kind of look at it, negative infinity, which I mean negative 0, which is just 0. 0 over infinity, right? Oops, sorry. So 0 over infinity is not 0 over 0 or infinity or infinity. Even though it looks like it's a indeterminate, it's not. Though that is not an indeterminate. So another way to think about it is that you have a 0, which is a small number, divided by a really big number. So if you have a small number divided by a really big number, you just get a smaller number, right? And as it becomes bigger and bigger, right? The infinity becomes bigger and bigger, this becomes even smaller. So it just approaches 0, right? Which is basically just the same. You could just think about how it works, right? A 0 divided by any number is just 0, which is just a general idea for math, right? So the limit as x approaches 0 of ln of ln x over 1 over x is basically 0, which is basically the same thing here. So this is 0 because you plug in x is 0. So technically, we were solving for ln of y, right? So our ln of y, the limit as x approaches 0 of ln of y is equal to 0. So basically, now our limit x approaches 0 because we were trying to not solve ln of y. We're trying to solve y. Our y was ln of x to the power of x, right? So that was our y, right? So basically all we had to do, generally all you had to do for all these cases for exponentials is that you just gotta raise this e to the power of whatever you have. So basically, we're gonna have ln of x, raised to the power of x is equal to just e to the power of 0. So e to the power of 0 is 1, right? So the limit as x approaches 0 of ln x to the power of x is equal to just 1. Okay? And that's the general idea of how that works. And now we're going to do the final case of indeterminates, which is basically 1 to the power of infinity. And for the example we're going to use on this one, we're going to use the idea of e. So like e, the 2.718, etc. Basically whatever that number is for e, we're going to prove how this works. So we have limit as x approaches 0 of 1 plus x to the power of 1 divided by x, right? So that's one idea for equaling to e. So how this works is basically, it's not really a proof, but shows why e is equal to e, basically, why this is equal to e. So the idea is that we're going to use, we need to check if there's a indeterminate of case 1 to the power of infinity. So x is 0, so it's just 1 plus 0 is 1. And 1 over 0 is infinity, so it's 1 to the power of infinity, right? So that is a indeterminate case of 1 to the power of infinity. So now we can just say it's y, right? It's equal to 1 plus x, 1 over x, and we change that, right? Ln of y is equal to 1 over x times ln of 1 plus, 1 plus x. Kind of running out of space. Actually, let's write this a little smaller so we can actually see the entire thing. So ln of y is equal to 1 over x times ln of 1 plus x. Okay? So we have this idea. Can I move this up so we actually get room later on? So now we have to find the limit as x approaches 0, right, of ln of y. So we have to find the limit of 1 over x times ln of 1 plus x. So is that a indeterminate basically? So 1 over, so because x is 0, right? So 1 over 0 is infinity times ln of 1 plus x. So we have 0 here. So 1, right? So we have 1 plus 0 is 1. So ln of 1 is 0, right? So it is an indeterminate of case infinity times 0. So all we have to do is basically make it a 1, f of x over 1 over g of x, right? And g of x, or g of x over 1 over f of x, right? So basically, this is our third exponential case. All the exponential case all do the same thing. So basically, you're always just gonna use this general idea of how to do it, this general process. So this ln of y. So we know this is an indeterminate. So let's just use the smaller example, the easier example, which is the polynomial. So ln of 1 plus x divided by the reciprocal of the reciprocal. So over 1 over 1 over x, right? Which is basically the same thing as just saying ln of 1 plus x divided by x, right? So is this an indeterminate? Well, we just plug in 0, right? So ln of 1 plus 0, because x is 0, so that's 0, and x is 0, so 0 over 0. So that is an indeterminate, 0 over 0, right? So now we use the Law Hopital Rule. So the limit as x approaches 0 of ln of y, right, is basically this. Now we do the Law Hopital Rule on the top. The derivative of ln of 1 plus x is just 1 over x. Well, since it's chaining, you had to chain, you have 1 over x, 1 plus x inside, you have to keep 1 plus x on the bottom. Okay? So the derivative of 1 plus x outside is just 1. Okay? So don't always remember to do your chain rules, your product rules, and your quotient rules. Okay? Just remember to differentiate between the Law Hopital Rule and the quotient rule. Quotient rule is different from the Law Hopital Rule. Okay, so Law Hopital Rule is derivative on the top and then the derivative on the bottom. Quotient rule is that you're gonna mix those together. So Law Hopital Rule doesn't do that. So don't do it. So x, the derivative of x on the bottom is just 1, right? So this just simplifies out to 1 equals to 1 over 1 plus x, right? Well, is this a indeterminate? Well, all you have to do is plug in x is equal to 0. So 1 over 1 plus x, where x is 0, is just 1 over 1 plus 0, right? Which is equal to 1. So this is not an indeterminate in any forms. So we know that the ln of y, the limit of x approaches 0 of ln of y is 1. So that's what we do know. Okay? So basically, we have a limit as x approaches 0 of ln of y is equal to 1, right? Because 1 is what we got. And we said our y was equal to our 1 plus x to the power of 1 divided by x, right? So if our limit as x approaches 0 of ln of y is equal to 1, that means our limit of x approaches 0 of y, of just y, would just be e to the power of what we got. So e to the power of 1, right? So it's equal to e. So the limit of x approaches 0 of 1 plus x, the power of 1 over x as it approaches 0, right, is equal to e. And that's like kind of a proof for E works, but it's more of an equivalence thing. So we know for sure that 1 plus x over 1 plus x to the power of 1 over x is equal to E, which is proven by the Law Hopital Rule. And that basically covers everything for part 9 of chapter 2. So thanks for watching, and in the next chapter, we'll be covering integrals.